Hey everyone, these are the ratios guided notes. A ratio is a comparison of two numbers. Ratios can be written in three different forms, with a colon, such as 2:5, with the word 2, such as 2 to 5, as a fraction, 2 to 5. The first quantity in the ratio is always associated with the first number. The second quantity in the ratio is always associated with the second number. For example, the ratio of beaks to wings in the birdhouse at the zoo is 1 to 2. This means for every one beak, there are 2 wings. The ratio of votes received by candidate A and candidate B, let's just say that is 5 to 3. This means for every 5 votes candidate A received, candidate B received 3 votes. Since it says candidate A first, that's associated with 5, and it says candidate B second, that is associated with the second number, 3. The ratio of boys to girls in this class, let's say, is 6/5. This means for every 6 boys, there are 5 girls. So it says boys, so that's the 6, and then girls, that's the 5. Practice. Explain the following ratios. The ratio of mix to water is 1 to 3. That means for every 1 unit of mix, there are 3 units of water. The ratio of weekdays to weekends is 5 to 2. That means for every 5 weekdays, there are 2 days in the weekend. The ratio of apples to orange is 7/5 or 7 to 5. So for every 7 apples, there are 5 oranges. Equivalent ratios are ratios that have the same value when they are simplified. The ratio of sugar to flour in Ted's cookies is 1 to 2. The ratio of sugar to flour in Jose's cookies is 2 to 4. Let's check if these are equivalent ratios by writing them as fractions. Ted's cookies would be 1 to 2 or 1/2. Jose's cookies 2 to 4 or 2/4. Ted's ratio is already simplified. Jose's ratio simplifies too. So if you look at Ted's cookies 1/2, that's simplified. Jose's cookies 2/4, we can divide the numerator and the denominator by 2, and then that simplifies to 1/2, because 2 divided by 2 is 1, and 4 divided by 2 is 2. These are equivalent ratios because they both simplify to 1/2. The ratio of girls to boys in Class A is 12 to 15. The ratio of girls to boys in Class B is 14 to 17. Let's check to see if these are equivalent ratios. So Class A we're going to write as 12 to 15, 12 fifteenths, and Class B we'll write as 14 17ths. Class A simplified, so we can reduce these by dividing the numerator and the denominator by 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Class B, 14 17ths, that cannot be simplified more. I know that because 17 is a prime number, so that number is already simplified. So 14 17ths. Are these ratios equivalent? No. Explain your reasoning. They do not simplify to the same number. Practice. Determine if the following ratios are equivalent. The ratio of miles for car A is 280 to 4. The ratio of miles to hour for car B is 180 to 3. Car A is 280 to 4. Let's write that number as a fraction, 280 to 4. And then car B is 180 to 3. So let's also write that as a fraction, 180 to 3. Let's see to simplify these, 280 to 4. I can divide both of those by 4. And I know that with the top one, because if I just look at 28, I know I can divide 28 by 4. So therefore, I can divide 280 by 4. So 280 divided by 4, well, that's going to give me 70 because 28 divided by 4 is 7. So 70 And then 4 divided by 4 is 1. 180 divided by 3. I know that 180 can be divided by 3 because 18 can be divided by 3. So numerator and denominator divided by 3. 180 divided by 3 is 60. 3 divided by 3 is 1. So it looks like they are not equivalent because they do not simplify to the same ratio. The ratio of blue to red candies in bowl A is 12 to 36. So let's write that as a ratio, 12 to 36. The ratio of blue candies in bowl B is 7 to 21. So let's write that as a fraction, 7 to 21. Going back to 12 over 36, I can divide the numerator and the denominator by 12. 12 divided by 12 is 1. 36 divided by 12 is 3. Going to 7 over 21, I can divide the numerator and the denominator by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. Since these reduce to the same fraction, they are equivalent ratios. We are going to make tables with equivalent ratios. David charges $15 for every lawn he mows. Let's put this in a table. Equivalent ratios are created by multiplying each quantity by the same number. All right, let's look at this table down here below. So it says David charges $15 for every lawn he mows. And we can already see that here in the table. For one lawn, it's $15. So now I want to figure out how much money he makes for 2 lawns. I'm going to multiply that number by 2. So 1 times 2 is 2. And then I'm going to multiply the $15 also by 2. 15 times 2 is 30. So I'm multiplying them by the same number. For how many lawns does he need to mow to get $45? I'm going to multiply each number by 3. 15 times 3 is 45. And then 1 times 3 will give me 3. So it shows me down here for multiplying by 4, 15 times 4, he would make $60. So then I'm also going to do 1 times 4, and that would be 4. So 4 lawns is $60. And then it wants us to write them as ordered pairs. So x comma y. So 1 comma 15, 2 comma 30, 3 comma 45, 4 comma 60. Plot the ordered pairs on the coordinate plane below. The y-axis is titled and labeled. Label and title the x-axis also. I'm going to plot these coordinate pairs down on my graph. It shows me that I already have dollars earned. That's my y. My x is going to be my lawns mowed. Okay, I need to write the numbers. For my lawns mowed, I am going from 1 to 4. So I can just go by ones down here. So 1, 2, 3, 4. All right, now let's plot my points. So for 1, it's 15. 2 to 30. 3 comma 45. That's 3 and 45. And then 4 comma 60. And then let's connect the points to make a graph. I just want you to notice that the graph is a straight line. Connect the dots on the graph you completed on the previous page, which we already did. If the ratios are equivalent, the graph will form a line, a straight line. So notice, going back to the previous page, notice that this is a straight line. That's because my ratios are equivalent. Jana reads 3 pages in 5 minutes. Complete the table below. So 3 pages is 5 minutes. So multiplying by 2, that will give me 6 pages because 3 times 2 is 6. Multiplying by 2, 5 times 2 is 10. And that's already there, so that's correct. Now we're going to multiply by 3 here. So 5 times 3 is 15. 3 times 3 is 9. That's done correctly. Now we're going to multiply by 4. 5 times 4 is 20. Therefore, 3 times 4 is 12. Now we're going to write the numbers as ordered pairs. So we have 3, 5, 6, 10, 9, 15, 12, 20. All of these should be equivalent ratios. We can check that by graphing them and see if it forms a straight line. Again, I already have my y-axis labeled. Minutes read is y, so my pages read is going to be x. Now, if I look right here at my pages read numbers, I'm going to be counting by 3 on my axis. So I have 3, 6, 9, and 12. Now let's graph the points. I have 3, 5, I have 6, 10, 9, 15, and 12, 20. Again, I am just graphing these coordinate pairs right here. Let's connect the dots, and it looks like it will make a line. There's my graph of my equivalent ratios table. How does your graph of Jana's reading help you know if the ratios are equivalent? A straight line is formed when connecting the points. Practice. Complete the table and graph below. Jose completes 3 miles in 27 minutes. So I'm going to fill that in right here because that's 27 is a number that it gives me. So 27 minutes is going to be 3 miles. So I also need to figure out 1 mile, 5 miles, and then minutes. I'm actually going to go backwards and figure out 1 first, because if I know 1, it's going to be easier to figure out 5 and then whatever this number is right there. So I need to figure out 1, and there's a couple different ways to figure this out. I can think about multiplication. I can also think about division, since that's just the inverse of multiplication. So if I have 1, what am I going to multiply that by to get 3? And that's going to be 3. So going down here, what number multiplied by 3 is going to give me 27? If I don't know that, I can think of 27 divided by 3, and that's going to give me 9. So he's running 1 mile in 9 minutes. Now, if I know that he runs 1 mile in 9 minutes, I can go back this way to figure out this one. So if he runs 1 mile in 9 minutes, I want to figure out how much time does it take him to run 5 miles. And that's going to be multiplying by 5. So 9 times 5 is going to be 45. So he runs 5 miles in 45 minutes. Now I got to go to 63. 9 times what is 63? I know 9 times 7 is 63. Therefore, 1 times 7. So he runs 7 miles in 63 minutes. Now I'm going to write the ordered pairs. So I have 1, 9, 3, 27, 5, 45, and 7, 63. Now we are going to graph these ordered pairs. It tells me my miles is X and my minutes is Y. Let's label that. My miles is going from 1 to 7, and it's counting by 2s. And then my minutes will be 9, 27, 45, and 63. Graph those. I have 1, 9, 3, 27, 5, 45, and 7, 63. And now I will connect those to make a line. Since it is a line, I know my ratios are equivalent. How does your graph of Jose's running help you know if the ratios are equivalent? A straight line is formed when connecting the points. Now we are going to use tables to compare ratios. Dan and Marie each want to have their own lemonade stand. The instructions for Dan's and Marie's lemonade mix are below. So it says 1 cup of mix to 2 cups of water, 2 cups mixed to 4 cups water. So this is Dan's lemonade and this is Marie's lemonade. There are various ways to check that a table shows equivalent ratios. You can check for the same multiplicative number either horizontally, meaning going across, or vertically, meaning going up and down. For example, looking at the first and second rows of Dan's lemonade, you can multiply each variable by. So if we're looking from here to here, notice that I can multiply each of those by 2. Or looking at the first and third row, so if I look from here to here, I can multiply each variable by 5, because 1 times 5 is 5 and 2 times 5 is 10. Horizontally, you can multiply the first column by what to get to the second column? So if I'm looking at these numbers right here, what can I multiply those numbers by to get to these numbers over here? And notice that these numbers are all double these numbers. So I can multiply across by 2. You can also check for equivalent fractions. For example, you can form a fraction from the rows. Looking at Marie's lemonade, check to see that 2/4 is equivalent to 3/6. 2/4 comes from this right here. 3/6 comes from that right there. So if 2/4 is equivalent to 3/6, let's check if they are. So we have 2/4 and 3/6. Those both will reduce to 1/2. Therefore, you know they are equivalent. Practice. Answer the questions below about the table. So we have Joseph's cookies, the sugar to flour ratio, and Laura's cookies, the sugar to flour ratio. Explain why Joseph's table shows equivalent ratios. Like I said, you can show this different ways. We can show the relationship going down between the rows, or we can show the relationship going across between the columns, or we could also check for any equivalent ratios. Let's do equivalent ratios, and I'm going to check for 9/12 and 12/16. This is just an example. You could do something else. So I have 9/12 and 12/16. 9/12 will reduce to 3/4 because I can divide the numerator and the denominator by 3. And 12/16 will reduce to 3/4 because I can divide the numerator and the denominator by 4. So the ratio 9/12 is equivalent to 12/16. Explain why Laura's table shows equivalent ratios. So again, I can reduce any ratios here. I can look for a multiplicative relationship going this way between the rows, or I can see if there's a multiplicative relationship going across between the numbers. I notice that this and this are multiplying by 2 the whole way down. So that shows that the table is equivalent ratios. Now it asks me which cookies have a greater proportion of sugar. Explain your reasoning. This is a ratio of 3 cups sugar to 4 cups flour. This is a ratio of 2 cups sugar to 4 cups flour. Let's write those ratios down. So we'll write down here where it says explain your reasoning because that will just show my work. So I have 3 to 4 for Joseph, and then I have 2 to 4 for Laura. Let's reduce those. 3/4 reduces to, the 3/4, and then Laura's reduces to 1/2. So since 3/4 is greater than 1/2, that means Joseph's cookie has to have a greater proportion of sugar. Okay, everybody, that's it for today. Thank you.